Hello, for this video, we will be solving elimination of arbitrary constants under differential equations. So let's get started. So for our first example, this would be 3x squared minus xy squared is equals to c. This type of problem is just an easy type. So first thing that we must do is to identify how many arbitrary constants are present in the problem. You can see there's only a single arbitrary constant, which is this one. Okay, so let's start solving. We we must derive this equation by a single time because there is only one arbitrary constant. So let's do that. The derivative of this is 3 times 2, that is 6. X 2 minus 1 is 1, and the derivative of x is dx minus, this is actually a product rule, that is u and v, u dv plus v du. Okay, so for u, that is nothing but x, and the derivative of y is 2y dy. Okay, plus copy v, which is y squared, multiplied by the derivative of x, which is dx, and the derivative of constant will always be 0. So simplify further, this is 6x dx minus 2xy dy plus y squared dx, which is equals to 0. Okay, so the best thing that we can do about it is to combine like terms, or I should say regroup for the dx and for the dy. So for dx, this is 6x and y squared. So that is 6x minus y squared dx. And for the dy, that is nothing but 2xy dy, which is equals to 0. Okay, and therefore that is the final answer. Okay, so for our next example, an easy type again. This is x sine of y plus x squared y is equals to c. Again, there is only one arbitrary constant, therefore we must differentiate this equation by a single time. So for the solution, this is actually product rule, x and sine y. So u and v. First, copy x. Derivative of sine y is cosine of y dy, okay? Plus v du. This is v. V, copy v, sine y. The derivative of u, which is nothing but dx. Plus again, this is product rule again. Copy x squared. The derivative of y is dy, okay? Plus copy y again. Derivative of x squared is nothing but 2x dx, okay? And the derivative of constant will always be 0. So again, simplify x cosine of y dy plus sine of y dx plus x squared dy plus 2xy dx is equals to 0. Next step is to regroup for the dx and for the dy. So let's start with dx. This is sine y, and for the dx, that is plus 2xy, factor out dx, okay? Plus for the dy, x cosine of y plus x squared dy, okay? Equals to 0. Therefore, that is our final answer. So for the third example, this would be x y squared minus 1 is equals to cy. So as usual, what we must do is to derive the equation by a single time because there is only one arbitrary constant. So let's do it. So derivative of this is product rule. So copy x, the derivative of y squared is nothing but 2y dy, okay, plus copy y squared, the derivative of x is nothing but dx, and the derivative of 1 is nothing but 0, and for this term cy, factor of c, derivative of y is dy, okay. So simplify further, that is 2x y dy plus y squared dx is equals to c dy. But at this example, we have seen that the arbitrary constant was not eliminated by performing the first derivative. So what we must do is to make use of system of equations. So mark this as equation 1, mark this as equation 2, and from equation 1 we extract the value of c. So from equation 1, using 1 we extract the value of c, and c is nothing but xy squared minus 1 over y, okay. Mark that as equation 3. So what we must do next is to substitute the value of c, which is equation 3, inside equation 2. So to do that, that is 2xy dy plus y squared dx, which is equals to c dy, and the value of c is nothing but xy squared minus 1 over y multiplied by dy. Okay, so to further simplify, we multiply both sides by y. So it would become 2xy squared dy plus y cubed dx, which is equals to xy squared minus 1 dy. And for simplification, we regroup the equation, dx for dx, dy for dy. Therefore, that will become, for dy, that is 2xy squared, xy squared. We transpose this to the left side. This would become negative. Therefore, 2 minus 1, that is 1, xy squared dy, and this negative 1, as we transpose it to the other side, that would become positive 1, and that is dy, which is, and for dx, that would nothing but y cubed dx. And for further simplification, that the final answer would be xy squared plus 1 dy plus y cubed dx, which is equals to 0, okay, which is equals to 0, which is equals to 0, okay. That is the final answer. So for our fourth example, this would be cx squared plus x plus y squared is equals to 0. So again, there is only one arbitrary constant. Therefore, we must differentiate this or derive this equation by a single time. Therefore, the derivative of 2 of x squared is nothing but 2cx dx derivative of x is dx, and the derivative of y squared is 2y dy is equals to 0. And again, we have seen that arbitrary constant was not eliminated. Therefore, we again use the last procedure that we did, or the last method that we did. We extract the value of c from equation 1. That is nothing but factor out negative, so we can carry on the preceding terms after cx squared, x plus y squared over x squared. We mark this as equation 3, okay, and we plug equation 3 inside equation 2 because we must substitute the value for c in order for us to eliminate c in equation number 2. Therefore, that will become 2 negative 2x plus y squared over x squared dx plus, okay, plus dx plus 2y dy is equals to 0. And again, to simplify it, because I want to eliminate this x squared, the denominator, so we must multiply it by x squared both sides. Oops, I forgot to write this x, that is 2x. Therefore, this will become negative 2x x plus y squared dx plus x squared dx plus 2x squared y dy is equals to 0. Okay, then we regroup it by dx for dx and dy for dy. So for dx, negative 2x squared plus 2 plus x squared, that is y squared minus x squared, okay, dx. And for dy, that would be nothing but 2x squared y dy, which is equals to 0. And again, to simplify further, we divide both sides by 1 over x. Therefore, the final answer would be y squared minus x dx plus 2xy dy is equals to 0. That is the final answer. But correction for this one, I forgot to distribute 2 for y at this part. Therefore, this will become 2xy squared negative, okay, and this has also 2 negative 2y squared. Therefore, that is the final answer, okay? For our fifth example, this would be this would be y is equals to mx plus h over m, where h is a parameter. Okay, parameter. So meaning to say our arbitrary constant will be letter m, will only be m. Okay, so again there is only one arbitrary constant, so we derive this one by a single time. Okay, so derivative of y, that is nothing but dy. The derivative of m, the mx is m dx plus the derivative of h over m, that is nothing but 0. Okay, so the value of m is equals to dy over dx, okay, which is also equals to y prime. So again, we plug in this equation 2 inside equation 1. So let's do that. That is nothing but y is equals to m. What is the value of m? That is y prime x plus h over y prime. And again, that is our final answer. So, for our last example, this would be a much more difficult compared to the previous examples. So this is example number 6. This is x is equals to c1 cosine of wt plus c2 sine of wt, where w is a parameter. Okay. So for these examples, for this example, uh, we have two arbitrary constants c1 and c2. So therefore, we derive the equation 2 times. So let's solve this. So first, what is the derivative of x? That is nothing but dx. And for c1 cosine wt, the derivative of that, factor out c1, the derivative of cosine wt, that is negative sin or sine wt multiplied by w dt, because the derivative of inside is w dt, plus c2, and again the derivative of sine wt would be cosine wt w dt. We factor out wt, c1 negative sine wt w, we factor out negative, plus wc2 cosine of wt, okay, and we divided both sides by dt. Okay, that is our first derivative. This is our first equation. This is our second equation. We derive it again. Derivative of this, that would become, that would become negative w squared, okay, dt quantity c1 cosine of wt plus c2 sine of wt, okay, and this is d over dx dt, because that is the second derivative. Okay, we just factor out w squared dt. So mark this as equation 3, and since using equation 1, we had x equals to c1 cosine wt plus c2 sine wt. What we can do is to replace c1 cosine wt plus c2 sine wt by equation 1, because it is already given that x equals to c1 cos wt, c2 sine wt. So by doing so, we must this side would be equals to the second derivative, that is nothing but d squared of x over dt squared, which is equals to negative w squared of x. Okay, and we transpose w squared times x to the right side, I to rather to the left side, so that we can have a positive value. Therefore, the final answer would be d squared of x dt squared plus w squared of x, which is equals to 0. Final answer. That's all. Thank you for watching the video. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy.